Okay, let's have a quick look at a working example here. We have a circuit containing a 12 volt battery. We have an ammeter, and that's in series to the resistor, and the resistor here is valued at 1200 ohms. We can just change that so it shows 1.2 kilo ohms. Alright, but it's the same value nonetheless. So let's say we want to work out current. Okay, we have our wee triangle, so we cover the I for current, leaving V and R, and you can see there's a line between both, which basically means divide. So we'll take the value of the voltage, which is 12, and we'll divide it by 1200 because it's in ohms. Okay, and that gives us 0.01. okay, amps. If we move the 0 to the right a few times, we get 10 milliamps, and here you can see the meter is also reading 10 milliamps, showing that we have the calculation correct. Okay, this time it's the same circuit, but we're looking to calculate the resistor value. So looking at the circuit, we have the 12 volt supply, you can see there. We also have an ammeter, and the ammeter is displaying 10 milliamps. Okay, and what we need to find out is what is the value of this resistor that's been hidden by a question mark. So if we look at our triangle, we cover the R with our finger because we're wanting to find R, and it's V divided by I. So the voltage is 12, and we divide by 0.01 amps. Now we need to remember that the meter is showing 10 milliamps, but because we're using 12 volts and the voltage is not in millivolts, then we need a common factor here. The Ohm's law only works in volts and amps and ohms. Okay, so we've got to convert the milliamps into amps. So 0.01 amps, and that gives us 1200 ohms. So the resistor value is 1200 ohms, or 1.2 kilo ohms. And as you recall, that matches up with the previous calculation.